5 years after we started certifying organic farmers, we switched to organic. And the challenge was, what is going to be what they now call our organic system plan? And it had to be sustainable so that I could pass it on to my children and my grandchildren and future generations. And I did not understand. I knew all the standards. I knew all the technical. I knew how to do it, but I didn't understand how you could configure your crop rotation in such a way that 300 years from now, the land would still be organic and productive and not run down, mined, okay? That solution didn't come easily. It took many, many years of doing basically applied research, if you wish, trying different things. And now by about the last 3 or 4 years, we've come down to an organic system plan, which involves a 9-year rotation, 9 years, 4 of which are in perennial alfalfa.
This is organic alfalfa. It's been grown for seed, but it's also grown for soil building. We fix a lot of carbon and nitrogen here over a 4-year period. It's very poor land, so we'll break it up when the alfalfa stand gets old. And we basically plow it down, and we crop it to annual crops, flax in particular, for 2 or 3 or 4 years, and put it back down to alfalfa. Let it regenerate the soil.
Medicago sativia, for those of you that like Latin. And that crop in that rotation, 4 out of 5 years, which means there's not a lot of money coming in because we don't want to sell the above ground portion for feed. We want the nutrients that are in that for that above ground portion. We want to save that. We can sell seed because it's only a couple of £100 to the acre. So we make some money on the seed because it's organic seed for sprouting and for other farmers to grow.
It's good stuff. This land would normally be in pasture or nothing, just grass. No animals, no usage. And right now it's productive farming.
The second or third year, the leggus bugs in, and sometimes grasshoppers show up, eat the blossoms. So years 3 and 4 of the rotation, nothing much happens. But during that time, all kinds of things happen. You get a fantastic improvement in the biodiversity of your soil organisms. You'll get granulation. It's coalesced into particles, and that's the way it was before the Europeans came and started breaking land. This is a restoration, the tremendous restoration. I can talk about that for half an hour. All the nutrients from subsurface depths brings them into that upper rooting zone for annual crops. Annual crops only root down 12, 18 inches. That's it. They don't go down there. They don't have time. It's the perennials that go down, okay? So that became the centerpiece of our rotation.
Well, we just plowed down a 4-year stand of alfalfa with a 6-bottom plow at about 5 to 8 inches in order to kill it and to put the carbon accumulate on the surface and all the debris, put it down and sequester the carbon, sequester the nitrogen. 4 years of alfalfa will take a piece of land that is run out of nutrients, infested with weeds, when we'll restore it back into productivity. So this is a base crop for an organic farm in the semi-arid Chernozemic, in the Great Plains region of North America.
How long can my descendants, my heirs and assigns, do this? And we did a calculation on one thing, phosphorus, because it's the second limiting factor. Carbon's from the atmosphere, nitrogen's from the atmosphere, phosphorus comes from the soil. And it doesn't come back. When you send it to the city people put it down the sewer, and the sewers take it to the lakes and rivers and to the ocean, and it's gone forever. So it's a mining process, whether farmers are mining on their own land or whether they're mining hydroxyapatite in Utah or Russia or Florida. Those are all limited deposits, non-renewable deposits of phosphorus. So in the top 6 feet of my farm, and most farms in the Central Plains region, you've got something like 300-year supply of total phosphorus, which is not available. It's highly unavailable because it precipitates with calcium and magnesium in our environment, and if you go into lattice-like or more acid soils, it precipitates with iron and aluminum. So it doesn't matter where you are in the world, phosphorus is not readily available, and it limits crop production. When that alfalfa gets broken, there is 5 years of nitrogen stored in that soil. And it comes out over 5-6 years. There's a period of slow release. The crop of choice for us is flax. It's got phosphorus attenuation mechanism. This plant works in symbiosis with a fungus, and that fungus then makes an exchange. It kicks some energy and sugar from the root hair from the flax plant. In exchange, it transfers phosphorus. So it basically increased the root system of the flax by 2 or 3 times. We don't know exactly how much. So now we're farming using biological microorganisms in our ecosystem.
It was originally a perennial back in somewhere in Europe or Asia. This highly lignified material sticks around for 2 or 3 years in the soil. So it helps us with soil condition, soil structure, basically tilth. The word tilth comes up a little bit. And we'll see what we got. Looks like we got one. This crop right now is $50 a bushel. Okay, $50 as compared to about $13 for conventional.
But you can't grow flax back to back. You should not grow any crop back to back. So you have to rotate, change organism, get rid of disease. So we bring in oats from time to time. So oats is a high demand crop. Lots of bushels. Flax we grow 20 bushel to the acre. Oats 100 or 80 bushel to the acre on organic farm. They're different volume, you got more bins involved, and lower price. And then, of course, the other crop comes in when you're in year 7 or 8. You worry a little bit more about nitrogen because now you're 4 years away from your main nitrogen source, the alfalfa. You need to think about using silage peas. Now, that's a whole story in itself. Silage pea has several advantages. The biggest one, of course, is it grows 4.5. We grew 4.5 feet tall this year. Very high carbon fixer. And fixes 120 pounds of N, which in today's vernacular is worth about $100 an acre of nitrogen available for the next year's crops. More than 1 year, release over time again. So you pop in some silage peas and you plow them down.
The Canada thistle you see in the background, it's negative, it's very competitive, it's allelopathic, but it's bringing up subsurface phosphorus, potassium, and other nutrients. And of course, it's fixing all the carbon. So, yes, it's obnoxious, and it is decreasing my flax yield. And that's one of the reasons why this is going back into alfalfa this year, regenerating. We've had a lot of issues with the Canada thistle here, and some wild oats. And it's run out. It needs to be regenerated. It needs to be restored. It needs 4 years of carbon-nitrogen fixation and weed suppression. I use the word suppression because control is not in our dictionary. What the Hamm family is doing here is sustainable for up to 300 years from now, and I can't speak beyond that, but I do know that we can sustain this for 300 years. That's based on my knowledge of soil science and agriculture. And that has to do for now. It has to do.